Now we're going to calculate the average speed at turn 11. And this is my actual distance time graph of my Formula One lap around the Barcelona track. And this part of the graph here is for turn 11. Now I'm going to teach you the second method to calculate the average speed from a distance time graph. And this method is called the gradient method. Now remember, the gradient of a distance time graph equals the average speed. So to calculate the average speed at turn 11, we need to work out the gradient of this part of the graph, which is the part of the graph for turn 11. Now I've already taught you how to calculate the gradient of any straight line graph in another lesson. So remember, we called the gradient m, and to calculate the gradient we used the formula the op distance divided by the along distance. And some students and schools call this the rise divided by the run. Now remember, to work out the op distance and the along distance, we need to choose two really good points along this line, and then we need to draw a triangle between those 2 points. Now you can choose any 2 points along this line, but I think that the best 2 points to choose are the points at the beginning and the end of the line. So I'm going to draw a triangle between these 2 points. So I take my ruler and I draw a triangle between these 2 points. And remember, my triangle must be drawn using horizontal and vertical lines only. Now we need to work out the op distance of the triangle and the along distance of the triangle. And to do this, we're going to have to read off some values from the graph. And remember, any time that we're reading off values from a graph, we need to draw a dotted line on the graph using a ruler and a pen. So to work out the op distance of the triangle, I need to draw a dotted line from this point across until it meets the y-axis. And I can see that this value here is 250 meters. Now a lot of students make a big mistake here, and they write down that the op distance is 250 meters. But this is completely wrong, because 250 is the value at this point. But this is not the op distance of the triangle, because the triangle did not start at 0. The triangle started here at 50. So I also need to draw a dotted line from this point here at the bottom of the triangle across until it meets the y-axis, which is at 50. And then I can calculate the op distance of the triangle, which is the difference between these two numbers. So if we started at 50 and we went up to 250, then the op distance of the triangle was 200, not 250. So make sure that you don't make that common mistake that a lot of students make. Now we're going to do the same to work out the along distance of the triangle. So I'm going to start at this point here, and I'm going to draw a dotted line down until we get to the x-axis, which is 10. And remember, this is not the along distance of the triangle, because the triangle didn't start from 0. The triangle started from here, 4, which means that the along distance starts at 4 and finishes at 10. So the along distance is 6. So we need to do 200 divided by 6. Now I do this on a calculator, and it equals 33.33 to 2 decimal places. So we've now worked out that the gradient m is 33.33. But remember, the gradient of a distance time graph equals the average speed. So this gradient is also the average speed. Finally, we need to write down the units of speed. To do this, we need to go to the graph and look at the units for distance and time. So because the units of distance was measured in meters and the units of time was measured in seconds, that means that the units of speed will be measured in meters per second. This is now my final answer. Now remember, meters per second isn't a unit that we would normally use in everyday life. And 33.33 meters per second is about 75 miles per hour. So turn 11 was much slower than turn 3. So we've now learned two different methods to calculate the average speed from a distance time graph. The first method is by using the formula speed equals distance divided by time, and the second method was by working out the gradient of the line, because the gradient of a distance time graph equals the average speed.